So this is a visual version of the problem that we were working on before we left about being able to use integrals to find a function value. The AP likes to ask this because it's, as usual, a more conceptual kind of problem. So you can see that they give you a picture of the derivative of f of x, and they show you from 1 to 3 and then from 3 to 8, and they give you the areas under the derivative. So from 1 to 3 the area is 5, and from 3 to 8 it goes under the curve and the area is negative 12. Now you're looking at the derivative in that picture to the left. There's the original function, but they don't show that to you. They do give you information that f of 3, the original function, so f of 3 equals 7, they want you to use that to find f of 8, f of 1, and then f prime of 3. So you have to really pay attention to whether they want the original function, the derivative, or sometimes the second derivative, but I don't have that in this case. So we're going to use that formula that we left off with, that you can basically find f of b if you know f of a and then can integrate from a to b. So I'm going to show the solution of 3 problems on the board behind this. So I'm going to move the screen. And so I drew a little picture on the left of what we were looking at so you can reference it, but obviously it's a video so you can go back if you need to. On the top, I'm noting they gave us f of 3 is 7. I'm going to use the formula that if I want to find f of something else, f of b, I can use f of something that I know, f of a, and add the integral from a to b of the derivative. So remember, the area of the derivative gives us the change of the original function. And if I take f of a and add the integral from a to b of the derivative, I'll get to f of b. So the solutions are as follows. If I want f of 8, I can use f of 3 to get it. So for a, I have f of 3 plus the integral from 3 to 8 of the derivative, and that, according to the formula, will give me f of 8. So f of 3 is 7. That integral from 3 to 8 of f prime of x I can get from the picture. 3 to 8 is that negative 12, so I substituted it in. And then I can just take 7 plus negative 12 and get my answer, which is negative 5. To get f of 1 is the same. If I want to get to f of 1, I'm going to start at f of 3, integrate from 3 to 1 of the derivative. Now, just to show you, because 3 to 1 is backwards, I swapped it. Remember, you're allowed to swap the integral so long as you change the sign on it. So to use it in the picture, I changed it from 3 to 1 to 1 to 3, just change that minus sign. So I can take f of 3, integrate from 1 to 3 instead, which I know the value of from the picture, as long as I subtract, and I just substitute it in. F of 3 is still 7. The integral from 1 to 3, according to the picture, is 5. I have the minus sign, so it's 7 minus 5, and 7 minus 5 is negative 2, which is my answer to part B. All right. Now in C, the difference is they want the derivative, not the regular function. So I have a picture of the derivative. So when they ask me for what's f prime of 3, I can just look at the picture and see that the y value for the derivative at 3, since that's a picture, it looks like 3 is a root. So f prime of 3, what's the y value of the derivative? According to the picture, it's a root, so it's 0. So these are 3 different problems they could ask. Notice one goes forward. It wants you to go from 3 to 8. The second one wants you to go backwards. It wants you to go from 3 back to 1, which you can basically flip it around and accomplish that. And then if they ask for a derivative, well, you have a picture of the derivative, so that they just want its y value in this case. If they wanted a second derivative, you would need a slope off of the picture that's on the left there. Now, you need more information to guess the slope. If someone asked me f double prime of 3, I would at least know it's negative, because in the picture at 3, the slope of that derivative is going downhill. So if someone asked me the second derivative at a certain spot, I wouldn't know it exactly from the picture, but I might be able to tell if it was positive, negative, or around 0. All right, so this ends that lesson that we were doing before on Wednesday, before all this stuff happened. So this problem was on the back of that other homework, but I'll put up a sheet that has some practice problems of something like this. All right, so this ends, I believe, goal 2, and the next video will have goal 3, and still working on integral applications. All right.